guys, this is Mrs. Bolin here with your notes for 9.1 day 2, some more properties of exponents, super fun stuff. So just a reminder of what we did yesterday, simplifying anything to the 0 power equals 1, super easy. Anything with a positive exponent stays exactly where it is, so that a squared just stays right where it is. But that b to the negative 5 has a negative exponent, which means that it's actually the reciprocal of b to the 5th. Or the way I like to think of it, it's negative and unhappy where it is, so we move it down to the bottom of the fraction, and now it is positive. So that is your final answer. Question number 3, that 0 only goes with the x. So that part, it means times by 1. 2 times 1 is just 2. This one over here, we've got 3 to the x. That stays exactly where it is. This y to the negative 2 is unhappy in the bottom. So we move it to the top, and now it is happy. So remember, we're doing the reciprocal anytime we have a negative exponent. And so when you do that, we now have a positive exponent. All right, so here's your exploration for today, the first little bit of it. So think about what 3 to the 6 means. That means I've got 3 times 3 times 3 times 3 times 3 times 3. And then I'm multiplying it by 3 squared, which means that I've got 2 3's. And then we're going to say, well, how many 3's is that altogether that's being multiplied, right? Because these parentheses don't really matter. If everything's just being multiplied, then it's like all of these things. So I'm going to count it up like 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to write 3 to the 8. Then I'm going to do the same thing with the 5. So I'm going to go, I've got 4 5's right here. 1, 2, 3, 4. And then I've got 5 more 5's. So I've got 1, 2, 3, 4. It's hard to say 3 and write a 5, you guys. I'm struggling just a little bit. But we're going to add up all of those 5's. I'm not going to add them. We're going to count them. Sorry. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 5's. So the way I would write that is 5 to the 9. And then now we need to generalize. So if I have the same base, and note, this is an 8 and this is an 8, this is a 3, this is a 3, 5, 5. This doesn't work if those are different numbers. Okay, you can't just times the numbers. It has to be the same base. So if we've got the same base x, all of these things just have that base. And then look at 2 and 4. How did I get 6? Plus, maybe? Does that work on this one? 6 plus 2 is 8. Yep. 4 plus 5 is 9. Yep. So really what we're doing here is we're just adding up whatever those exponents are. So m plus n. Okay, so now we're actually going to try some problems. Oh, the missing blank here is add, because that's what we did to the exponents. If we are multiplying powers with the same base, I add the exponents. Okay, so now let's try some practice problems together. Shift down here a little bit. So question number 1, I keep the base, and then I say if I have 2 of them and 6 of them, now I have 8 of them all together. That was just from our practice up above. Question number 2, my base stays the same. If I have if I have 4 2's multiplied out and 7 2's multiplied out, all together, I'm going to have 11 of them if I count them all up. Okay, and if you ever forget the rules, just write them out. Sometimes it's a little bit annoying to write out 11 2's. So that's why we simplify and try to look for patterns. But that will always work. If you guys forget the properties, just go back and write it out. Okay, this one, you can think about it 2 different ways. You could either just add these up to begin with. Negative 3 plus 2 is negative 1, plus negative 6 is negative 7. And so you could just say, oh, that equals 7 to the negative 7, which is the reciprocal of 7 to the positive 7. Another way to do it would be to get rid of the negatives first. So if I have, actually, we're not going to do it that way. That's what we're going to learn on the next one. So never mind, just add them up. When we start talking about the fractions, that's when we'll get into that in the next little section. Okay, so for number 4 here, if I add them up, 4 plus negative 6 gives me negative 2. And then that is equal to 1 over 10 to the positive 2. Remember, it's unhappy in the top, so we put it in the bottom. And typically, if we have these really big numbers, we just leave it written in exponent form. Sometimes when we have ones that are really easy to do, we would leave it as 1 over 100. You just do whatever your teacher tells you to do. I would say either one of those answers are acceptable. Typically, if the power is like 5 or higher, I would just have my students leave it in exponent form instead of multiplying it out, especially since it says write your answer using positive exponents. All right, question number 5. -9 and +9 makes 0. I know that anything to the 0 is equal to 1. And then this one over here would just be y to the 10 because I just did 2 plus 8. Okay, so we've got a little bit more exploring to do because this is only half of the lesson. We just looked at what happens if we're multiplying. Any ideas what the next one's going to be? Opposite of multiply? Divide. That's what's coming up. You guys are smart already on top of that. So let's go ahead and look at the next exploration here at the top of page 54. So we're going to write these out. So if I have 3 to the 7 on top, that's like having 3, 3, 3, 3, 3, 3, 3, 1, 2, 3, 4, 5, 6, 7. Perfect. And then I've got 4 on the bottom. 1, 2, 3, 4. I can cancel things out that are the same in the top and the bottom, right? So I can cancel 1 of the 3s, 2 of the 3s, 4 of the 3s. I mean, 3 of the 3s, 4 of the 3s. Okay, so I can cancel out 4 of them. So your question is, well, how many are left? I have 1, 2, 3 3s. And since there's nothing left on the bottom, I don't need to write that part of the fraction anymore, okay? Let's look at this one. I've got 5, 5, 5, 5. I've got 4 of them. And then 1, 2, 3, 4, 5. I'm going to cancel any that are the same. So I have a 5 left on the bottom. What do I have to put in the top just to save the spot? Have to put a 1 there, okay? Because in order to give that the value of a divide by 5, which is what we have to put something in the top. If we put 0, then it would take away its value. So the only thing that we can put there where it doesn't change the value of that divide by 5 is when we put a 1 there, okay? And really, 5 goes into 5 one time, and each of these makes a factor of 1 is really what we're doing. And so really, we're doing 1 times 1 times 1 times 1 times 1. Every time we cancel these, it really is making a 1. Okay, so that's why we have to put that there. All right, last part of this exploration is looking at what did we do? We had 6 and 2, and we ended up with 4. We had 7 and 4, and we ended up with 3. We had 4 and 5, and we ended up with 1 there on the bottom, okay? So what we're going to do, the way we got those numbers, and we just subtracted them, right? Every time we cancel it off, it subtracts from how many are left. So I would have x, again, making sure that it's the same base that you have for both numbers, to the m minus n. And technically this is like 5 to the -1 because we subtracted, which if we wrote it with positive exponents, it would be 1 over 5 to the +1. And remember, when we have exponent 1, you don't really have to write it. If you've got 1, 5 there, it's implied that it's an exponent 1. Okay, oops, and I just realized that is behind my little camera. All right, you guys, so when we divide powers with the same base, we subtract their exponents. Okay, so let's look at question number 7. We are going to subtract those. And the shortcut that I tell my students so that you don't have to write it as a negative and then change it so that it's positive in the bottom is I just say, if we're going to cancel this, where are there more x's and by how many? In this case, it's not x's, it's 6's. So where are there more 6's in the top or the bottom? I've got 5 in the top, 8 in the bottom. I'm going to say, well, there are more 6's in the bottom and I have 3 extras. Remember, we just put the 1 there to make sure that we keep that in the bottom of the fraction, and that is your answer. Okay, so same thing on this one. Where are there more b's, top or bottom? They are in the bottom, and there are 5 extras. Okay, so that is your answer for that one. On this one, where are there more z's? There's more in the top, and there are 5 extras in the top. Where are there more A's? In the top, and there are 2 extras. Okay, remember we don't have to save the spot for the bottom because divide by 1 is the same thing as just writing this exactly how it is. Okay, this one, remember if there's no exponent, you could put a little 1 there just to remind you that I have 1 of them. So I say, where are there more B's, top or bottom? There are more B's in the bottom, and there are 2 extra. I'm going to put a big 1 there, different than the little exponent one. I'm going to put a big 1 there to save the place so that I know that this is a divide by b squared. And then I'm going to do the same thing for x's. Where are there more x's? There's more in the bottom by 2. Where are there more y's? There's more in the top by 1. So here's your notes, you guys. If we are doing a product of powers, we're going to multiply. In order to multiply, we are going to add the exponents. When we are dividing, we are going to subtract the exponents. And that's just because we're canceling. That's what the subtraction represents. Okay, so we're going to flip it on over to your homework assignment for today. I'm going to go through the odd problems with you guys, and hopefully you can figure out the even ones by looking at the odds. And make sure you write your answers down on your paper so that you can take a picture of it, get credit for showing your work. Okay, this one, where are there more 5s, top and bottom, top or bottom? There are more in the top by 4. So that's the answer on that one. This one you would say, where are there more negative 6s? On the top by 3. And then you could actually multiply that out. This one we could multiply out, which would be 625. I'm not sure which of the answer. Hopefully it says in the assignment whether they want you to leave it in exponent form, expanded form, or simplified form. Okay, question number 3, I would have 4 negative 9s all together if I'm multiplying all of those out. Question number 5, I would have, I add those up, so I get 6 to the negative 3. And what that really represents is 1 over 6 to the positive 3. Remember, it's unhappy where it is, so I move it to the bottom. Now it is positive and happy because our directions say use only positive exponents. Okay, for this one, I'm just going to add them up. So I have 2 to the 9. Oops. You guys, I accidentally did an even one for you. Okay, let's move on to number 7. So now we're going to ask ourselves, where are there more x's, top or bottom? There's more in the bottom because there's 8 of them and there's 2 extras. I have to put a 1 on the top to save my spot. Question 9, I'm going to add all of those up. Remember, I'm going to have a z. I just put the little line through it so it doesn't look like a 2. But now I'm going to add them up. 8 plus 2 is 10. 10 take away 5 is 5. And I know you guys, this is hard because there's a dot right there that represents times. Do not times those. We're adding them up because what we're multiplying is the z's. So if I were to multiply out 8 z's and 2 z's all together, I'd have 10 of them. And then I'd be dividing by 5. And so I keep canceling out 5. And so that's why I have 5 left. Okay. Question number 11. The question is, where do I have more x's, top or bottom? I've got more in the bottom by 3. Where do I have more y's? I have more in the top by 2, and that is it. Question number 13. Where do I have more A's? Well, the only A's I have are in the top, so I'm going to write them in the top. Where do I have more B's? In the top by 1. You could write a little 1 if you want to, but the simplest way to write this is just 1b there without any exponent. That's our final answer. Number 15, where do I have more A's, top or bottom? Top by 3. Oh, and the B's are the same, so they would just cancel. So I really don't even need that fraction bar. I'm just going to turn that into a box to box my answer. And that is it for 9.1 day 2.